Hello viewers, welcome to Mobilemaths with Gamchang. So today I want us to look at June 2023 paper 1. Okay, so we'll go through it together and I'll assist you how to answer such a paper. Okay. So the first part of the question is saying neither mathematical tables nor slide rules nor calculators may be used in this paper. So what it means is we are not going to be using any calculators. So we'll try to help each other how to go through such a paper when we are not using a calculator. Okay. So the first question is saying express 54.497 correct to the nearest tenth. What happens here is, guys, is this. You see the first 5 here, this is our tens, which then the 4 here is our units. Okay, then the next 4 here, 0.497 there, the first 4, that's our tenth. Then this one will be our 100th. Okay, going on. So when we are to correct to the nearest tenth, we are considering this 4 here. So how do you correct it? You check the next value, this one. Is it a 5 and above? If it is a 5 and above, it means our 4 is going to be a 5. If it is 4 and below, then we just remain with our value as a 4. So in this case, because we have a 9, this value here is going to be 5.45. Sorry, it's going to be 554. This is going to be 54.5, like that. Okay, that will be the answer. So an example whereby maybe it's not a 9 here. Let's say we have 4.47, like that. Then the answer would be 5.44. I don't know why I'm liking 5.4 here. I don't know why. Okay, so this will be the answer there. You don't have to change, round up. It will remain the same. Okay, let's move on. Now we have this question and we are to write it in standard form. Standard form is a times 10 to the power of a, like that, where a is any number from 1 to 9. Okay, it cannot be 10. So in other words, it's 1 digit. Then our n can be positive or can be negative, either of these. So how to go about this? You find out I have the easiest way that I do. What I do is this, guys. I move my comma this side. If I'm moving that side, and also because I have zeros, it means I'll have a negative power. So how many numbers do I have to move? I'm moving 1, 2, 3, 4. So it means it's going to be negative 4 there as my n there. So writing my answer, it will be 3.42 because I've moved my comma there. Okay. Then times 10 to the power of, we have moved going this side, minus 4. So it will be minus 4, like that. That will be our answer. Okay, let's move on. Now we are to correct these two significant figures. Okay, so you find out, let me write this, 478.367. okay, so when they say two significant figures, it means we are considering these two first values. Okay, because they are non-zero numbers. So you look at the next number. Is it a 5 and above? If it is a 5 and above, it means we are going to change this 7 to 8. Okay, so I'm going to have 4, 8. But if you now check, our values were 3 before the comma. So we add a 0 to maintain those 3 numbers before the comma. So our answer becomes 480, like that. Okay, let's move on. Okay, now we are asked to find, simplify, giving the answer as common fraction in its lowest term. Okay, let's do it, guys. So what you do, you find a common denominator for this. So the easiest way that I can do is say 7 times 3, we get 21. So it will be my common denominator for these two. Then I'll say 7 into 21, I'll get a 3. Then I'll multiply it with this 2 there. Okay, so it's going to be 3 times 2. Okay, plus 3 into 21 there is 7. So I'll have a 7, then times 1 like that. Okay, let's simplify. This will give me 3 times 2, that's a 6, plus 7 times 1, that's a 7 over 21. Okay, let's add 6 plus 7, that will give us a 13 over 21. And we cannot simplify it further. This becomes our answer. Let's move on. Now, I've got this question here, which is saying 2 over 5 divided by 10. So the easiest way that you can do this question is to rewrite it and say, this is 2 over 5 divided by 10 over 1. When I have 10 is the same as 10 over 1, because 10 over 1 will give me a 10 like that. Now, when we have it like this, it's simple. We can now simplify it. When we have a division, we can change this division sign and have it as a multiplication. Then when we do that, we invert. This becomes the bottom and then this becomes the top. So it will be 2 over 5 times 1 over 10 like that. Okay. Now let's simplify. 2 can go into 10, 5. Okay, and we can further simplify that. So what we have here is 1 over 5 times 1 over 5. So it's like you are multiplying the top parts on their own. You are multiplying 1 times 1 here and also 5 times 5 there. So you will get yourself 1 over 25 is your answer. Okay, you don't have to sweat much because it's just 1 mark. Let's move on. Now we have this here, this value. 18 over 35 times 14 over 27. Okay, so for this one I can divide. Let's simplify and see. 7 can go into 14 and have a 2 there. 7 can go into 35 and I have a 5. Okay, 3 can go into 18 and we have a 6. 3 can also go into 27 and I have a 9. Okay, I can also divide 3 here. I have 3 into this one. That will give me what? A 2 here. Okay, that will give me a 2 here and 3 here. Okay, so I'll have like 2 times 2 over 5 times 3. Okay, yes. So 2 times 2, that is a 4, over 5 times 3, that's a 5. We simplify it and we leave it like that. It can not be further simplified. Let's move on. Okay, here comes the decimal numbers. Evaluate giving the answers as exact decimals. So what you do, you rewrite it and say 0.024 like this times 0.3 like that. Okay, so we are multiplying. Okay, so when multiplying, I'm going to say 3 times 4 here. I'll get 3 times 4, that's 12. So I have 2, remainder 1. Then 3 times 2, that's a 6, plus 1 here, it's going to be a 7. Okay, so this is this part here, okay, of multiplying. Now, when we want to see how many decimal numbers it is going to be, we are going to count. Here at the top I have 3, here I've got 1. So I'm going to have 4. So I'll add 0, 0. Now I have 4 before comma, then I add a 0 like that. So you find out this is corresponding 3 here plus 1 here, 4, which is the same here as 4 there. Okay, so this balances. So our final answer is 0.0072 like that. Okay, without using a calculator. Let's move on. Okay, now we have 0.4 to the power of 3. So this is the same as 0.4 times 0.4 times 0.4. Okay, so for me, the easiest way I can do is say 4 times 4 times 4. When I say 4 times 4, I get 16 times 4. I'm gonna get 64. So I can write my 64 like that. Okay, now having my 64, how many decimal places do I have? 1, 2, 3. So I also have to have 3 here. So I'm going to add a 0 there. Then I can say comma like that. So my final answer will be 0.064 like that. So that is our final answer like that. Okay, let's move on. Express 0.224 as a percentage. There are two ways of doing this. Either the first easiest way, you can simply say, so the first one I can simply say 0.224 times 100% there. Okay, because it's already a decimal, so it means it's already over a certain fraction. So I'll get myself 22 because I'm moving with these 2 zeros there. So this comma will also move 2 and will come there. Okay, so it's going to be 22.4% like that. Okay, fine. Or else, if you want to go the longer way, which is the longer way, I can say this 0.224 is the same as 22.4 over, because I have 3 digits there, it means I have 0, 0, 0, 3 zeros like that. So this is the fraction of 0.224. Then I multiply it by 100 like that. So I can cancel off these zeros like that. Then I'm going to say 10 into 22, that's a 2. 10 into 20, remainder 2. 10 into 24, that's another 2, comma. 10 into 40, that will be a 4. So we get our 22.4% like that. Okay, fine. Let's move on. Number 4. Okay. The first question is saying list elements of set M. Okay, so we have our universal set, which is 75, 6, 7, 78, 79, and 80. Okay, then the first M there is even numbers. So these are numbers that can be divided by 2 only. Okay, those are even numbers. Okay, then multiples of 4, these are numbers that can be divided. This can be divided by a 4 there. Okay, so let's write those. So the first one is saying list elements of M. So I can say my M is going to be elements divided by 2. I can have 76, 78, and 80 there. Okay, so let's write those. So it's going to be 76, 78, and 80 like this. So these are the elements. We are done. Let's move on to the next one. List elements of set R. Okay, our R, we said it's multiples of 4. Okay, so let's see which numbers can be divided exactly by 4. You find out 75, we can't. 76, yes. 76 can be divided by 4 here. 4 into 76, that's 1. Remainder 3 can go into 36. There we have 14. Okay, fine. So we can have it there. Okay, fine. Let's see another one. 77, no. 78, we can't also. 79, no. 80, we can. Okay, so it means for R there, we are having elements of R. These are 76 and 80 like that. Okay, let's move on. Now the next question is saying, part B of the question is saying, find n of m dash u r. What it means here is we want to find the number of elements that are not in m, then we combine with those that are in r. So what I can say is this. We had our m was, let's go to our m. Okay, so this is our m. Okay, looking and comparing with our universal set, the elements that are not in m are equal to 75, 77, and 77 here. This is 77. Okay, then we also have 79. Okay, so these are the elements that are not in m. Okay, that's first step. Now we want to combine these elements that are not in m with the elements that are in r. Okay, so our r is down here. Okay, so let's combine. If I combine these two, what do I have? You find out my m union r is going to be equal to, I'll have 75 here, 76 down there. Okay, I have 77. I have 77. I also have 79. I don't have 78. Then I have 80. So this is the union there. Now to write n of m complement of m complement union r, we can count these numbers here. 1, 2, 3, 4, 5. So there are 5 there. So we can say this is equal to a 5. Okay. Let's move on. Now number 5 is saying simplify this expression. Okay, so what we do, we remove the brackets here, we remove the brackets there. Okay, let's remove 2 times a, we get 2a, minus 2 times minus 2 there, we get a minus 4. Then this last part there, we have minus 4 by a, that will be a minus 4a again. Minus 4 times plus 3, we get a minus 12 like that. Now we can take this one there, okay, and then this we combine it with there. You find that we will get 2a minus 4a minus 4, then minus 12. Okay, so the final answer will be 2a minus 4, we get minus 2a. Then minus 4 minus 12, that is minus 16 there. So that's the final answer for that question. Let's move on. This question here is asking us to find, express 3 over m minus 2 minus 2 over 4m plus 3 as a single fraction. Okay, so what we do, we find the common denominator. So you can simply multiply these two and say our common denominator is going to be m minus 2 and 4m plus 3 like that. Okay, so this is our common denominator. Now to get our numerators, we are going to multiply, we are going to divide the denominator by this one. Then the remainder, we multiply it with 3. We do the same for the 4. So I'm going to say minus m minus 2 into this whole thing here. Okay. Or else, what I'm trying to say here is this guy. Because we have got a common denominator here, m minus 2, 4m plus 3. You will simply come here and multiply with the same denominator, m minus 2 and m 4m plus 2 there. Okay, then you also do the same this side, m minus 2 and then 4m plus 3 like that. Okay, such that when you do this, m minus 2 there will cancel off with that and you remain with 4m plus 2 is going to multiply with 3 minus, for this other side, 4m there is going to cancel with that. Then we have 2 and m minus 2. That's what I'm simply going to do. I hope this makes sense to someone who is trying to read using the these videos and write their November exams. Now let's remove the brackets. 4m times 3, that's a 12m here. 2 by 3, that's plus 6. Then we go to the other bracket there, this one. We are moving to the other bracket, this one. Okay, let's simplify. So it's going to be minus m minus 2m. Okay, then plus a 4. Minus 2 by minus 4, minus 2, that's a 4 there. And our denominator is m minus 2, 4m plus 3. Okay, now let's combine like terms. Okay. I think there's something that I did there. I don't know. There was yeah, now I see what I've done here. Okay, yes, I've seen what I've done. This is a 3, guys, not a 2. This is a 3, yes. Okay, so this was going to give me a 9 here. Yes, that's correct. Fine, let's simplify. Please don't make such errors, eh? At least it's for me now. So I have 12 plus 4. Okay. Oh, no. I have, let's combine this step by step. I have 12m minus 2m. Then I've got plus 9, then plus 4. Sorry for confusing, guys. M minus 2, that's our denominator. 4m plus 3 like that. Okay. Now we can simplify with these ones separated like that. So we are going to get 12m minus m, that's a 10m, plus 9 plus 4, that's a 13, over m minus 2, and then 4m plus 3, like that. So this is our single fraction. Okay, let's move on. This was just 2 marks. Okay, now this question is saying state the special name of a quadratic quadrilateral with 4 lines of symmetry. So when it means 4 lines of symmetry, what it means is like you can fold something 4 times and it will be matching. That's what I can say. That's the easiest. Like the sides will be matching together. Okay, now let's do this. Which one? For this one, I can say it's a square. A square is like this, guys. So it means I can have it folded that way. Okay, then it will be like this. Okay, then I can also fold it this way. Then it will be like this. Okay, I can also fold it like this. Then it will be something like this. Okay, then I can also fold it this way. Then we have something like a small triangle. So the sides will be corresponding and matching. If you can just find a square and fold it the same way that I'm doing, and then it will come. So that's a square here. Okay, we can say a square. Fine, let's move on. The next question is saying a quadrilateral has interior angles of that. Okay, so you find out a quadrilateral, like for example the square that we have just talked about. It has 90 degrees there, 90 degrees there, 90 degrees there, 90 degrees there. So the sum of interior angles there is 360 degrees. So if we want to find the value of x there, we can say x degrees plus 2x there plus x plus 10 there. This is this part here. Plus the x plus 50 is equal to 360 degrees. Then we simplify. Okay. So it means I'm going to have x plus 2x, that's 3, plus x, that's 4x, then plus this x, we get ourselves 5x. So I'm getting 5x here. Then I have 10 and 50, so it's going to be plus 60 degrees here is equals to 360 degrees. Okay. So I can take this, that side, and it becomes a minus. So I'll have 5x is equal to 360 degrees minus 60 there. So we get here 300 degrees is equal to 5x. So we are going to divide all the sides by 5 and we get our x value. So you find out if we divide 5 there, 5 there, 5 into 30, that's 6. So we get our x value is equal to 60 degrees. So that's the value for our x. Okay, let's move on, guys. Now we want to find, they are saying P varies directly as the cube of R. Okay, cube means 3, square, that's 2. Okay, so we can write this and say, so normally when they want us to find a formula connecting, they can say formula, they can say law, they can say equation. It's one and the same thing. Okay, now let's find that. Okay, so we are saying P varies directly as R cubed, like that. Okay, then to remove this proportionality sign, we introduce a constant. We say P is equals to K R cubed. Normally we use K, we use H. Sometimes when now it's combined, we can also use a C, capital letter C. You will see as we do some more question papers. Okay, let's finish off. Now, to find the value of K, we are going to use these values that we are given there. Okay, so we are saying P is 2, so I have 2 is equals to K. R is 4, so this is 4 cubed. So 4 cubed is 4 times 4 times 4 times 4, like this, 3 times. So here you find out 4 times 4, that's our 4 times 4, we get 64 here. Okay, like that. Okay, so it's going to be 2 is equals to K times 64, like that. Then to get your K, we divide by 64 here, divide by 64 there. Okay, so this we can simplify this, they cancel off each other. 2 can go there, 1, 2 can go there, 32. So you find out our k value is equals to 1 over 32. But this is not the law. The law now is this one. Okay, so let's rewrite it. We will find out we have p is equal to 1 over 32 r cubed. If you want, you can write it as p is equals to r cubed over 32. It's the same thing. Okay, let's move on. Okay, now they want the value of p when r is 8. So we can use that law that we said p is equal to r cubed over 32. So our r is 8. So this is going to be p is equals to 8 cubed over 32. 8 cubed basically is 8 times 8 times 8. And when we do that, we get ourselves 512. So we are going to have p is equals to 512 divided by 32. If you divide this, you get a 16. Okay. So you do step by step. You start by 2 into 32 and you do that up until you get to 16. Okay. That's how I did it. Okay. Now let's move on to number 8. Okay. Number 8 is saying, given that, I like to use blue, given that m plus 3n is equals to 5, okay, then m squared minus 9n squared is equals to that. Then they say find the numerical value of m minus 3n. You find out this here, guys. This here is a perfect square, this part, okay? When it's a perfect square, we can write it as m plus 3n and m minus 3n. That's what it is. So this is equal to minus 15. Okay. Now, having this part, guys, we can now simplify and say, okay, fine. We know that this whole thing is equal to a 5 from there. So I can write this 5 and m minus 3n is equal to minus 15 like that. You see? I've eliminated m plus 3n because we were given here. Okay. Now with this, I can divide everything by 5, everything by 5. So this 5 and 5 cancels. 5 here, we get minus 3. So my m minus 3n is equal to minus 3. So that's the numerical value of m minus 3n there. Okay, let's move on. Then they want us to find the values of m and n. You find out now we have two linear equations that we have generated, the one for m plus 3n and the other one for m minus 3n. So for the m minus 3n, we got m minus 3n is equal to minus 3. Then for the m plus 3n was equal to a 5. Okay. So for me to solve this, I'm going to say, okay, I can eliminate m by adding everything here. If I add, this will give me a 0. Okay, so I'll have 2m here is equal to minus 3 plus 5 there, I get a 2. Dividing by 2 here, dividing by 2, you find out my m is equal to a 1. Okay, let's find our n using any equation from these two. I can use this plus here. So I have m plus 3n is equal to a 5 there. Okay. So this is going to be m. We know it's 1. So it's 1 plus 3n is equals to 5. So my 1 can go this side, and it becomes a minus. When it goes there and becomes a minus, I now have 3n is equals to 5 minus 1. So this is 3n is equals to a 4. To get my n, I'm dividing by 3 by 3. So our n value is equals to 4 over 3, like that. If you want, you can change it and say it's 1 and 1 over 3. It's still fine. Okay, let's move on. Number 9. Okay, given that p is equals to that, make m the subject of formula. There are many ways of making m the subject of formula, but I'm going to go through the easiest one. This one, I'm going to cross multiply with q plus m so that I remove the denominator here. Okay, so I'm going to multiply here by q plus m and also this side by q plus m. Okay, such that this side they cancel off each other, and I'll have p multiplying q plus m this side is equal to a q like that. Okay, so I have pq plus pm is equal to a q like that. Okay, what are we looking for? We want m, so I can take this one this side, and it becomes a minus. Okay, so I have pm is equals to q minus pq like that. To get my m, I'll divide here by p and divide this whole side by p. So you find out, if I do that, this will cancel off each other. So my m is going to be equal to q minus pq over p. You can leave it like that, or you can take a common factor here, q, and say this is going to be q 1 minus p over a p like that. It's still fine. So that's the m there. Now let's move on to the next question. So the next question is saying find m, so we are going to use that expression there. Okay, fine. I'll use the one that is simply not complicated without the factorization. This one, no, I'm using this one. Okay, fine. So we said our m is equals to q minus pq over a p like that. What are our q value? Q is 3 minus p is 2, q is 3 like that, over p is 2 like that. Okay, let's simplify. 3 minus 2 times 3, that's, so we have got 3 minus a 6 there over a 2. So we have got 3 minus 6, that's a minus 3 over a 2. So this is our final answer like that. Okay, let's move on, guys. Okay, fine. I'm gonna zoom in here. So whenever I see such a question, you know, I just try as much as possible to fill in the information that I can get from the details that I already am given. Okay, then I can answer the questions later on. Okay, so we are given in the diagram points QSR on the circumference. So those are the QSR there. And we have a center O. Okay, then we've got line PTQ. So there's a T here. Okay, fine. Is a tangent to the circle of Q. Then we are given M, we are given N and P and Q is 70 there. What else? We are also given OQR, ORS is 25. Okay, fine. So what it means here, guys, is this. I can find from here, I can find P. Okay, P, I can find it and say, okay, P, the value here at the center there is twice the one that is at the circumference. So it's going to be my P is equal to 2 times 70 degrees there. So I get my 140 degrees as my P there. Okay, let's move on. I can also now find this angle here, this one here. Okay, angles at a point they add up to 360. So I can say that reflex angle there is going to be 360 degrees minus 140. I will get 220 degrees here. So I can say this is 220 degrees. Okay, then now you find out here, guys, I have got this cyclic quad, this one here. These are 4 sides. So it means all those sides I can add them and they should give me a 360. So if I can add them, I have one unknown, this one. I can simply say my n is equal to 360 degrees minus 220 minus 70 minus 25. Then I get my n. You see, that's how I can do it, because all of them added together, they should give me 360 degrees. So if you do that, you find out our n value is going to be 45 degrees. Okay, so here it's 45 degrees. Let's move on. Okay, now because of this tangent here, and then this radius that is going to the center, you find out this angle here is 90 degrees. Because it's 90 degrees, I can say my m value is equals to 90 degrees minus 45 degrees of n. So my m is equal to 45 degrees. So this is 45 degrees. Okay, now let's go and answer the questions. Find m. So you find out our m value is equal to 45 here. Okay, we said our m is 45. So you can say 45, and if you want to find write the reason, you can say it's the angle on a tangent and radius. Okay, that's the reason. Let's move on. Find n. We said n was 45 again, so this is 45 degrees. The reason we said angles in a cyclic in a quadrilateral, angles in a quadrilateral add up to 360 degrees. Okay, like that. Let's move on. P, okay, let me see my P was 140. Reason was the center is twice the angle at the circumference, guys. Okay, so we can say our P is 140 degrees. Reason angle at the center is twice angle at the circumference, like that. Okay, so that's the reason. Let's move on. Okay, fine. Now this question is saying evaluate 766 base 9 plus 143 base 9 again, giving our answer in base 9. So we are not changing anything here. So let's do that. So I have 766 base 9 plus 143 base 9, like that. Okay, let's add. 6 plus 3, we get 9. So I'm going to say 9 over our base. So it's going to be 9, we get 1, and we say remainder 0. So we write our remainder there. So we are going to say 0. Then we write our remainder there. Okay. Or else what I can also do or say is that when I say 6 plus 3, 9, I cannot write 9. How many whole numbers do I have? 9. So I cannot write 9. I'm going to say 9 minus 9, that's a 0. So I write my 0 and I carry a 1 because there was a whole set of 9 there. Okay. Then we have 6 plus 4, that's a 10. So I can say then plus 1 there. So it's going to be 11 divided by 9. So this is going to be 1 remainder, remainder 2. We can write our remainder and we carry our 1 there. So we now have that value. Then we have 7 plus 1, that's 8, plus this carried 1 here, that's a 9. So we have again this same scenario. So we have a 0, we write our remainder. Then we say carry 1. We don't have anything else, so we can write our 1. So our answer is 10, 20 base 9, like that. Let's move on. Okay, now they want us to find the convert 356 to a number in base 2. So what you do is going to be going via root of base 10. Then from base 10, you go to base 2, like that. Okay, so let's go to base 10. So this is 356, like this. You can raise the base to powers of, say, 6 to the power of 0. And then here 6 to the power of 1, like that. So you can have 3 times 6 to the power of 1 plus 5 times 6 to the power of 0, like that. So this is going to give us 3 plus 5 times 6 to the power of 0. Any number to the power of 0 is 1. So we have a 5 here. So this is giving us 23 base 10. Okay. Now we are going to base 2. To go to base 2, we are going to divide long division our base 10 number here by the base where we want to go, which is 2. 2 into 23, so it's going to be like 2 into 2, 2, 1. 2 into 3, 1. Remainder, 1. Okay. Then 2 into 11, that's a 5. Remainder, 1. 2 into 5, that's 2. Remainder, 1 again. 2 into 2, that's 1. Remainder, 0. 2 into 1, that's 0. Remainder, 1. So we divide up until we get a 0 at this point. Then to write our number in base 2, we take it from the bottom going upwards. So you find out it's 1, 0, 1, 1, 1, base 2, like that. Okay, let's move on. Okay, now we have a question that is saying, given a function f of x as 4 minus x and that one. Okay, fine. Find f of 0. So what it means when we have this, for every x value we put a 0. That's what it means. So this is going to be equal to 4 minus, for every x we put 0, this will be a 0. Then we have got x again, 0 minus 0.5, like that. So this is 4 minus 0, that's a 4, times 0 minus 0.5, that's a minus, we get a minus 0.5 here. Okay, minus 0.5 is the same as half, so I can say this is 4 times minus 1 over 2, like that. We get ourselves minus 2 as the answer. Okay, let's move on. Now we are on number 12. Okay, number 12 is saying, so we have this graph here. This is an inequality. In the diagram, the unshaded region R is defined by 3 inequalities. Yes. Okay, find the 3 inequalities. Okay, fine. We want to find the inequalities. Okay. So here, guys, you find out just by looking at this. I have got myself here. I have this here, this line here. It's a straight line, which is this is going to be a y graph, okay, because there is no x is 0. Then I have also this one, which is my x. There's no 0 there. So these are the 2 points that I can have. Okay, so for the y, you find out this point here is a 2. Okay, so I can say my y is going to be, since we are not considering this part here, I can say my y is going to be greater or equal to a 2. That's one inequality. Then for x now, this value here, let's see what is the value here. Okay, the scale is saying 1, 2 here. Okay, 3. So it means this is 1.5. So we can say for x, this is going to be greater than or equal to 1.5. Okay, the thing is here, guys, for this equal to that I'm using, you find out here we've got solid lines. All these are solid lines. That's why. Now I'm left with this line here. Okay, let's find that. So you find out now for the third inequality, to find it, basically what we are doing, we can find the equation of a line that is passing through this point and also this other point here. Which other point is easier? Okay, this other point there. Okay, so for this one, my coordinate is 6, 0, because this is my x, this is my y. Okay, then for this upper top here, my x is 0, my y is 6. So this is x, y. Okay, so I can say, if I want, I can say this is going to be my y2 here, x2 here, and then y1 here, x1 there. Okay, so to find the gradient, if you want to find the equation of a line, let me go down. Equation of a line, guys, is you find the gradient. We have a standard form, which is y is equals to mx plus a c. So our m is our gradient. So our m is equals to change in y over change in x. Our change in y is y2 minus y1 over x2 minus x1, like that. So my y2 was 0. Okay, was 0. So I have 0 minus 6 there, y1, over my x is 6 minus 0. So you find out I'm having minus 6 over a 6. So our gradient is minus 1, which makes sense with considering the way it's lying. When it's like this, you have a negative gradient. When it's like this, it's a positive gradient. Okay, so that's number 1. So we have our gradient. Then C here, guys, is our y-intercept, where the graph cuts the y-axis. So you find out it's cutting at 6. Okay, so if it cuts, the equation of my line is going to be y is equals to m is minus x, then it's minus 1. So it's the same as minus 1x there, plus our 6, our c is 6. So this is our equation there. Y is equals to x minus x plus a 6. But it's not an inequality now. To consider what is our inequality, what you do now, you can take any point. I'm going to take this point here. I have 3, 3, and check if it's valid. We said our equation is y is equals to minus x plus a 6. So if I say 3, 3, this is going to be 3 is equals to minus 3 plus a 6. So I have 3 is equals to minus 3 plus 6, that's a 3. So it means it's valid. Okay, when it's valid, it means our equation there is going to say all the values of y are going to lie below this value there. Okay, because if I take, for example, if I am to take 0, 0, this one here, oh, that's not a 0, 0. If I'm to take 0, 0, for example, it will be 0 is equals to minus 0 plus 6, which is not balancing because I have 0 is equals to a 6 there. It's not balanced. So it means this whole side here, it will be our region, which will be wanted. Okay, it's wanted region there. Okay, so we can say our equation now as an inequality is going to be y is less or equal to minus x plus a 6. Okay, less, it means that our value of y should be greater than. Okay, then we consider it that it is valid. Or else you can rewrite this and say this y is plus x is less or equal to 6 like this. Okay, it's still the same way. Okay, let's move on. Okay, number 13, we are saying we've got ratio of heights, okay, of cylinders, two similar cylinders. A cylinder is something that is like this, guys. Okay, so this is this other cylinder, and then we've got another bigger cylinder here like this. Okay, so this will be 16 and this will be 48 centimeters. Okay, so they are saying write down in its simplest form the ratio of heights. So the ratio of heights, we have got 16 centimeters as to 48 centimeters. Okay, so we can divide here 16 into 16, that's 1 as to 16 into 48, that's 3. So our ratio is 1 as to 3 like that. Okay, let's move on. Volumes. Okay, volumes, basically we are looking at a volume factor. Our ratio of height was 1 as to 3. So when it's volume, we are basically cubing, multiplying each term 3 times. So you find out when I say 1 times 1 times 1 is to 3 times 3 times 3. That's basically what we have. 1 times 1 times 1, we get 1 as to 3 times 3 times 3, we're getting ourselves 27. So this is the ratio of volumes there. Okay, let's move on. This part here is saying the curved surface area of the larger cylinder is 500 cubic centimeters. So we are dealing with area now. So they say calculate the curved surface area of the smaller cylinder. So for the bigger, so we had the bigger and the smaller. So we are looking at area factor. So we said our height factor was 1 as to 3. So when it's area, it's squared from here. Okay, so I have 1 times 1 here as to 3 times 3. That's what we are having. So we have 1 as to 9. That's the area factor that we have. So we can use this. So we're saying when we have 1 is for our smaller. Okay, so we can say when we have 9, factor of bigger is as to 500 cubic centimeters there. Square centimeters, sorry. Then for 1, which is for the smaller there, it's as to what? It's going to be less. When it's less, we can say 1 over 9 times 500 there. Okay, 1 over 9 times 500. So if you divide this, you are going to get yourself 55.555 going on. So you can round it off and say it's going to be 55.6 centimeter squared like that. Okay, let's move on. Okay, we are given that a sum of money is shared in the ratio 2, 3, 4. The smallest share is 160. Okay, so here the total ratio is going to be what? We are simply saying 2 plus 3 plus 4. This is our total ratio. We get 9. So this is total ratio. Okay, is 9. Okay, then they are saying the smallest is getting 180. So smallest is 2 there, so it's getting 160 there. So I can say 2 as to $160. What about 9 as to what? As to more. When I have more, I'll take the bigger number. 9 over 2 times $160 there. So my 2 can go into 16 there, and I have an 80. Then I have 9 times 80 there. I'll get $720 like that. Okay, we are done. Let's move on. Okay, now they are saying find the time taken for 4,000 to earn a simple interest of $400 at a rate of 5%. Okay, fine. So you find out our 400, this is our principal value. Then our $400, this is our interest. Okay. Then our 5 there, that's our rate R here. Okay. So our formula says I is equals to PRT over 100. Okay. So what are we looking for? We are looking for T. So if I want, I can just make T the subject of formula, or else let's use it directly like this. Okay. My interest is 400. So I can say 400 here is equal to P 4,000 times R 5 times T over 100 like this. Okay. So I can divide the 100 there and say these, they cancel off each other. So I have 40 times 5, that's a 200 T, and then you have a 400. Okay, so I divide by 200 here, divide by 200 here. So our T is gonna be, they cancel off each other there. 200 into 400, that's 2. So our T is equals to 2 years. Okay, like that. Let's move on. They are saying solve the following equations. Okay, so we remove brackets first. 3 times x, that's 3x, minus 3 times minus 2, that's minus 6, is equal to 5x plus a 3 like that. Okay, so it is easier for me if I take my 6 this side and then my 5 that side. Okay, or else I can take, anyhow it works. Okay, fine, let's do that. Let's do that. So I'll have 5x going this side is going to be 3x here, 3x. Then I've got minus 5x, okay, is equal to 3 plus a 6, okay. So I'm going to get 3x minus 5x. What do we get? We get ourselves 3 minus 5x, that's a minus 2x there. Okay, then I've got is equal to 3 plus 6, that's a 9. So I'll divide by minus 2 by minus 2 here. Okay, so our x value is going to be equal to minus 9 over 2, which is the same x. X is equal to minus 4.5. Okay, let me just check something here. Okay. Okay, that's fine. Let's move on now. Okay, now we have this question. Okay, the easiest way that I do is this. I have q minus 2 over 9 to the power of 2. To remove this power here, I'll divide by 2. So when I'm dividing by 2, it's like I'm multiplying 2 by 1 over 2, like that. So I can also come this side and multiply by 1 over 2, like that. When I do that, a number to the power of half is the same as q minus 2 over 9. Here they cancel off each other, is equal to square root of 49 over 81, like that. That's the same. Any number to the power of half, it's the square root of that number. So I'll have q minus 2 over q over 9. This is a 9. Sorry, this is a 9. Yes, a 9. Okay, is equal to square root of 49, that's a 7. Square root of 81, that's a 9. So this is what I have at the end of the day. I can take this whole thing going this side and it becomes a plus. So I have q is equals to 7 over 9 plus 2 over 9. These are same bases. So it's 9 plus 9. It's a 9 base here. And then 7 plus 2, that's a 9. So our answer of q is equal to a 1. Okay, let's move on. Okay, so now we are on number 16. It's saying evaluate 0.0469 times 2.13 by first estimating each number to one significant figure. Okay, so let's do that. For the first one to one significant figure, you find out we have got 0, 0. These are not significant figures. We don't count them. So we start at 4 there. Then we check the number that is in the next number. Okay, let me just zoom in first. Okay, so we check the next number here. We check this number here. So it's going to be 0.05. We round it up. Times, for the next one, this is a first significant figure. Then this number is 1. We cannot round up the 2 to 3, so it will remain like that. So it will be 2.0 there if you want. But because it's one significant figure, you can write it as 2 like that. Okay, so this is going to be over. For this one, 2, this one is a 2, so we can't round up, so it's going to be 2 plus 3 point. This one, 8 here will round up 3 to 4, so we have 4 there, times 2.06, so you have a 0 there. It's not changing, so it's times 2 here like that. So this is what we have come up with. Let's simplify this. So this is going to be 0.05 times 2, we get 0.1, okay, over 2 plus, we are going to say 2 plus 4 times 2, we deal with this first using BOMDAS or Mobilemaths. So we get 8 here, so this will give us 0.1 over a 10. 10 into this value there, it means we are just increasing the number of decimal. We get 0.01 like that, okay? Fine, let's move on. Now we have solved the equation 27 is equals to 3 to the power of 2d plus 1. So what you do, you also write 27 in terms of base of 3. So you find out the number that can give us is 3 times 3 times 3. So it's 3 to the power of 3 there. Okay, so let's use that one. So I will rewrite that. This is 3 to the power of 3 is equals to 3 to the power of 2d plus a 1. So when they have the same base like this, it means you can equate the powers there. So I can say 3 is equals to 2d plus a 1. Okay, so now we can solve this equation. So I can take my 1 there, it becomes a minus. So I have 3 minus 1 is equals to 2d like that. Okay, so 3 minus 1, that's a 2, is equals to 2d like this. We divide by 2, this cancels off each other. So it means our d is equals to a 1 like that. Fine, let's move on. Number 17. Okay, fine. We are on vectors, guys. So whenever they give us vectors like this, this is our x value, this is our y value, x, y, x, y. We can even rewrite this in terms of column vectors. Say this is 4, 8 here like this, and this is minus 4, 0 like this, and this is minus 6 and a 4 like that. Okay, fine. Now they are saying points E, F, and G have coordinates like this, respectively. O is the origin. Okay, so it means we are taking these from the origin. Okay, so if we are to draw, these are all coming from the origin like that, like that, like that, something like that. Okay, that's what we are just saying from that. Okay, now let's answer the question. Express as column vectors. So these were the column vectors that we have done there. EF. So when they say EF, what you do to get your EF, you are simply saying F minus E. Okay, so but we don't have F per se because we are relating to OG, so we can say we say F minus E like this. Okay, so we don't have F per se, we relate it to the origin, so we can say OF minus OE like that. Okay, these are now vectors. So our OF, this is, let me just write, the first one was OE, this was OF, and then this was OG like that. Okay, fine. So our OF in this case is minus 4 and a 0 there. Okay, minus OE is 4 and a 8 like that. So we are subtracting corresponding these upper tops together and the bottom ones together. That's how we do the vectors. Okay, it's more like the same as matrix. Minus 4, we get minus 8. 0 minus 8, we also get a minus 8. So this is the final answer of EF. Okay, when we put this arrow, it shows the direction. Okay, let's move on. Now we are on the next one is saying minus half G, half GF. Okay, so what it means, we are coming from F or F minus OG. That's what it means. And we have a half outside which is minus like that. That's what it means. So I can simply say minus half. I'm gonna work out this and say our OF was minus 4 there and a 0 like this, minus OG minus 6 and a 4 like this. Okay, so simplifying this, I have my half outside by minus 4 minus minus 6, we get a plus. This here becomes a plus here. Okay, so we'll get minus 4 plus 6, that's a 2. Then at the bottom, 0 minus 4, that's a minus 4 here. Okay, so this is our answer. Now let's multiply with our scale factor here. This is a scale factor. If we multiply with our scale factor, we are going to get everything inside. You are multiplying by minus half. So it's like minus half by 2, we get minus 1. Then minus half times minus 4, we get ourselves a 2. So this is our final answer there. Okay, let's move on. Okay, now they are saying find EF and also FG. Okay, so I'm going to do it the longer way. I just want to do the longer way. EF, so that you understand. EF, we said it's OF minus OE. Okay. Then plus FG, that's OG minus OF. Okay, like that. Let's simplify. So you find out for this one, OF was minus 4, 0, minus OE was 4, 8. Okay, let's simplify. Plus OG is minus 6, 4, minus 4 and a 0 like this. So you can either add all of them together at once and say, okay, fine. This is minus 4, minus 4, minus 4. I get minus 8, then minus 6 there, that will be minus 14. Then we say plus a 4 there, you get yourself a minus 10. But I don't want to confuse you, so I'm going to do it step by step. Okay, so minus 4 here, I have minus 8. We have this answer anyway. Then 0 minus 8 there, minus 8 there. Plus the other part, minus 6 minus minus 4, that's a minus 6 plus 4. So we have minus 2 here. Then 4 minus 0, that's a 4. So this is what we have. Then we end here. Minus 8 plus minus 2, that's a minus 10. The one that we got when we did the whole thing there. Okay, so fine. Minus 8 plus 4, we get minus 4 there. So this is our final answer there, guys. Okay, so you can either work it from here if you want and say, okay, I'm gonna add this, like this, like this. So minus 4, it's like you have minus 4 plus minus 6, then minus 4 like that. That's where we got our minus 10. Then you do at the bottom, you have got 0. So you have 0 minus 8 plus 4, then minus 0 there. We get ourselves minus 4. So it's the same way. Okay, but that was a longer way. Then the last part is saying find magnitude, leaving the answer in said form. So we want magnitude of OE. We have calculated OE, and we said our OE was equal to our OE. Actually, we know our OE. OE is equal to 4 and an 8 here like that. So when we want magnitude there, magnitude of OE here like this, it means we want square root of 4 squared plus 8 squared like this. We will get ourselves 4 squared, that's 16, plus 8 squared, that's 64, is equal to, if we add this 16 plus 64, that's 80. Okay, so in said form, you can either leave it like that, but you can even simplify. 80 is the same as square root of 16 times F5. of which square root of 18 we know it's 4. So we can say 4 square root of 5 like that, okay? That will be a perfect answer there. Okay, now let's move on to number 18. Convert, they are saying convert 2 gram per cubic centimeter to kg per meter cubed. Okay, fine. So you can do it step by step and say, okay, I'm going to convert 2 gram per cubic meter to first in I'm going to convert grams to kgs. Okay, so when we are converting grams to kgs, we find out to convert from gram to kg, you divide by 1,000 like this, or you multiply by 1,000. Then to move from cubic centimeter to cubic meter, you are now also going to divide by 1 over, because it's cubed, it's gonna be cubed 100 times another 100 times another 100. So there are 6 zeros like that. Okay, fine. Let's do it. How do we do it? So I'm going to say 2 divided by 1,000 like that to go to kg. Then also divided by 1 over that 1, 2 zeros, 2 zeros, 2 zeros. Okay, because the idea here comes from here. Let me just explain this. Okay, when I'm converting centimeters, 100 centimeter is equal to 1 meter. Now when it's squared, you are simply squaring this and squaring this. So it will be 100, and you add another 2 zeros. When you are cubing, again, so this will be also equal to m squared like this. When you are cubing, you are simply saying to the power of 3 there. So it will be like 6 zeros here like this. Then it's also 1m cubed like that, centimeter cubed like that. So that's where it is coming from, guys. Okay, I don't want to confuse you, but I want to help you. Okay, so we are dividing like this. So the easiest way I can say is gonna be 2 over 1,000, sorry, times this. I invert, okay, because I'm now saying times. So it will be this zeros here over 1. So I can cut 3 here and cut 3 there. So I have 1,000 by 2. So you find out we are going to get 2,000 kgs per m cubed. That will be our answer. Okay, let's move on to the next question, part B. Okay, part B is saying a map of a town is drawn to a scale of 1 centimeter to 9.5 kilometers. Calculate the actual length of the road in kilometers, that is 3. Okay, so basically we can just use ratios here. 1 centimeter, we are saying, is equal to 9.5 kilometers. What about when it's 3? 3 centimeters is going to be more. When it's more, you take the more at the top, 3 over 1 times 9.5 kilometers. So it's going to be 3 times 9.5. We get our answer as 28.5 kilometers. Okay, 28.5 there. Let's move on. Okay, now we are given area of a town on the map is that. Okay, so remember we said 1 centimeter was s to 9.5 kilometers. Now when they say area, now it means we are squaring here. Okay, so I can square here and I can also square here. When I square here, it means here I'm just saying 9.5 times 9.5. Okay, that's what we are doing there. You find out 9.5 times 9.5, we get ourselves 90.25 kilometers squared. So this is s to 1 centimeter squared. Okay, so we have a new ratio here of area. Okay, now we are using area factor. This is more like an area factor. Okay, like that. This is an area factor. Okay, so when we have our area factor, we are given that the actual length area is 361 kilometer cubed squared there. What about in the map? So it's going to be here more. It's going to be more than 1 there. So when it's more, it means these values, I'll take the one that is bigger on top. So I have 361 over 90.25, and I multiply by 1. When we find out, we get ourselves 4 cubic centimeter. 4 squared centimeter, not cubed. Cubed is to the power of 3 squared. Sorry about that. Okay, now let's go to number 19, guys. We are almost there. We are almost there. Yes. We have a village A is on a bearing of 0.92 from a village B. Okay, so if they say from, so you start from that one. So I can have my B here. Let me have my B here. So this is my B and this is my north here. Okay, so they are saying it's at 92 is more like, this is 90 here. So when it's more like 92, it's more like this. Okay, that's my 92. So it means my A is here. I will draw also my north there. Okay, so this is our A like this. What is the next part? Then they are saying calculate the 3-figure bearing of village B from A. So now we want to check the village of B from A. Okay, so we are now here and we want to view what is the bearing, 3-figure bearing of B from A. So you find out we use our north there. We are going to move here and go up to that point like that. So that's the angle that we want. Okay, and you find out here already we have 180 degrees. Okay, so I can say we have got 180 degrees plus, then we have this portion here. Okay, what is that portion? You find out here I've got a Z angle. I can either take it like this or I can take it like this is a Z angle. This angle here is equal to this angle there. Okay, fine. Anyway, anyhow that you want, you get it there. So it means this portion here is also 92 degrees, in other words. So I can add 180 degrees plus 92 degrees and I'll get myself 202 by, that's a 29, that plus 8, that's 17, 1, 2, 70. Okay, so I'm getting 272 degrees. That's a 3 significant figure bearing. Okay, let's move on. Part B of the question, we have got this. Okay, so here, guys, we have a center. This is our center also. It means that this is a radius here. This is a radius. And also this is a radius here. Okay, so it means this is also 9. Okay, so they are saying we're also going to take pi to be that is also very important. The angle is 84. Okay, so the first question is saying calculate the length of arc PQ. So we want length, this length here. Okay, PQ. Okay, you find out we have a formula, guys, for calculating length of an arc. And the length of an arc we can say is equal to, we can say theta over 360 degrees times 2 pi r. Remember, arc or length of a cylinder or a circle is 2 pi r. But because we have an angle, it will also affect our length there. That's why we have theta over 360. Now let's substitute what we have. Our theta is 84 over 360 times 2. Our pi is 22 over 7 times our r, which is 9, like that. Let's simplify and divide. Okay, so I can say here, let me see, 3 can go here. How many times? 3 can go into 9. I can say 3 can go there. 1, 2, 0. Okay, what else? 3 can also still go there. 1, 3 there. I can have a 40. Okay, so I have a 40. Fine. Then 2 here can go into 40. I have 20. Okay, 2 can go into this one. I have a 10, into this one 11. Okay, so now I have something like this. I have let me write it, 84 over 10 times 11 over 7, like this. Okay, and I can now simplify it and I can get 84 times 11 divided by 70. That will give me like 13.2 centimeters. So that's the arc length there. Okay, fine. Let's move on. The next question is saying area of the sector OPQ. Okay, so you find out area of a sector. Area of a circle is pi r squared, guys. But because we have an angle, we're going to say times theta over 360 degrees. That's where it comes from. Anyway, our theta is 84 degrees over 360 times our pi 22 over 7 times our r 9 squared over 1. Okay, so if you punch in the calculator or if you simplify this, I'm not going to do that, you get yourself 59.4 centimeters squared. Okay, you can try to do it the same way we did, and remember this is 81 here. This is 81. Okay, fine, let's move on. Okay, number 20, we are saying model form is what? We have this form here. Table above shows enrollment at a certain school. So we've got form 1, form 2, up to form 4, and then we have got the enrollment, the number of students we have in form 1, 128, in form 2, 127. Maybe, you know, some are going and so on. When we have form 4, they are now 120, you know. Okay, so they're asking, what is the model form? Model form, we are just saying the class that is more number, okay, that has got more students. You find out the form is form 1. Okay, form 1. Okay, it's form 1. Okay, that's the model form. This one, it is 128 there. Okay, let's move on. Calculate the mean number of learners per form. Okay, the mean is basically average. Okay, how many forms do we have? 4. How many students do we have? So we are going to add, mean is going to be equal to, so you can say mean is going to be equal to 128 plus 127 plus 125 plus 120, all divided by 4. We have 4 forms there. Form 1, form 2, form 3, form 4. If you add this, we are going to get 500 over 4. So our number is going to be 125 learners, okay, or students. Okay, let's move on. We have done that one, 2 marks. Okay, then they are saying 2 learners are chosen at random from the school. Calculate the probability that both learners are in form 3. Okay, when they are saying both learners are in form 3, let's go back and see. Okay, so when they say both learners are in form 3, it means we are having 125 over total. We added these numbers here, guys. We added all these numbers. The total was 500. Okay, so we can say the probability is going to be 125 over 500. Okay, times, okay, we check again now. If we have 125 and the probability is saying what? 2 learners are chosen at random from the school, and calculate the probability that both are in form 3. Okay, both are in form 3. So what it means is this: if I have taken one here like this is one student, then I'm now picking another student, it means the total has changed. I no longer have 500, I now have what? 499. Okay, then from 125 also I have subtracted one student. What do I have? I now have 124. So I have 124 times divided by 144, 444.99. So we multiply that. If you multiply this, you find out you get your probability is going to be 31 over 499, like that. That will be your probability. Okay, let's move on to the next question. Okay, this way I've done. Okay, we are on number 21, guys. Fine. I hope you can see this clearly. This is a 7. I think it's clear. I think it's okay. We can work with that. Okay, 7, 7, 3 there. X plus 2, 2x minus 4 there. Okay, so I'll just rewrite 7, 7, 3. Yes, x plus 2, and then here I've got 2x minus a 4 there. Okay, fine. Then they are saying the first question. I'm not gonna read this whole thing, I'm not good with reading anyway, but I know the information that is represented on the diagram is that information we are given there. We can read it anyway. In the diagram above, x, d, f, and y, e, g are two straight lines which intersect at O. Okay. Then xy is ed and gf are parallel. Okay, that is very important here. They are parallel. These ones are parallel, parallel, and parallel there. Okay, fine. OX is equals to OD. Okay, and then OD is 7 centimeters. Okay, then DF is 3, ED is x plus 2, and GF is 2x minus 4. Okay, fine. Then they're saying the first question, name the triangle in correct order which is similar but not congruent. Okay, this is very important. Not congruent here. To triangle x or y. Where is our x or y? X or y is this one. Okay, fine. So what you do is this. The one that is not congruent, it means it's not the same size but same angles. You find out this angle is equal to this angle. So I can have the O at the center there. So it's going to be equal to. Then this angle is going to be equal to this. So if it's also equal to this, it's also equal to that. Okay, fine. So it means my triangle is this one, guys. In other words, let me just rewrite it, and I can say, I said I have O at the center because of O here at the center. That's the similar and to triangle x or y. Okay, in the correct order. Then you find out it's equal to triangle FOG, like that. FOG, this one, like that. Okay. Now let's go to the next question. Congruent to triangle. Now congruent, it means they are of the same size. So it means we now take this other smaller size here, this one, but we take it in the correct order. So the correct order of it's what? It's still triangle. Congruent is still triangle x or y is now congruent to triangle D or E. Okay, because they've started with x there, this one, which is similar to this one. Okay, that's why I'm starting with a D there. Okay, fine. Let's move on. Calculate length of FG. Okay, length of FG. I can use the same principle there of this triangle of congruent there. Okay, fine. Let's see. From these, I can say, since they are congruent, OX over, okay, now I'm gonna use the one that is not congruent, because we have known sides here and we have known sides there, and we are looking for this bigger side, which is FG. So we're gonna use this relationship here, the first relationship which was not congruent. Okay, so let's use that information. So we said triangle x or y was similar but not congruent to triangle F or G. What it means was this: XO was going to be the same as XO length over FO there. Okay, FO. Okay, you see how I'm doing this. Then I can say which is equal to OY. So if I take OY there, length of OY, I'm also taking OG there. Okay, so it's over OG there. Is also the same as if I take X and Y here, I also take F and G. Okay, so it's gonna be XY over FG, like that. Okay, I'm just taking the sides, guys, from here. I take OX, this one, and I related to that one. Okay, then I also took XY, this one, and related to that one. Okay, then lastly I took this one and related it to that one. Okay, that's what I did. But now with this information, I'm gonna use the sides that have values. You find out I've got this one and this one, they have values, and we are also looking for this one, so I will also take the corresponding there. Okay, so let's use that information. So it means I'm going to use this one and this one. Okay, our XO is 7 over 7 plus 3, that's a 10, is equal to xy. Xy is xy. Let's go to xy. Xy is this one, guys, but we don't know its value, but it's congruent to this one, which is x plus 2. So we are going to use that one. Okay, so let's use that one. So it's going to be x plus 2 over fg, that's a 2x minus 4 there. So we can simplify this and cross multiply this one there and this one there. So I have 7 by 2x minus 4 is equal to 10 by x plus 2, like that. Okay, simplifying 7 by 2x, 7 times 2x, what do we get? We get 14x. 7 by minus 4, that's minus 28, is equal to 10 by x, that's 10x, plus a 20, like that. Okay, so I will take this one this side and then this one this side. Okay, it becomes minus, the other one minus 20, it becomes a plus. So I have 14x minus 10x is equal to 20 plus 28. Okay, so we are getting here 4x is equal to 48. Okay, we divide by x, divide by x. So our by 4. Sorry guys, we are dividing by 4 here, by 4 by 4. Okay, so our x value, 4 into 4 1, 4 into 8 2. Our x value is equals to 12. Okay, but this is not the final answer. Remember, our fg is equals to 2x minus 4. So if our x is 12, so it means it's 2 by 12 minus a 4. So this is going to be 2 by 12, that's 24, minus 4, we get ourselves 20. So it means fg is equals to 20 centimeters. Okay, that's fine. Let's move on. Oh, we are done. We have matrix M, which is equals to 5 minus 2 minus 3 minus and 2, and matrix N, which is that. The first question is saying find inverse. So when we have to the power of minus there, it's inverse of M. So what you do, you can do this. You can say this is your A, your B, your C, and your D. So inverse, you're going to say you find determinant first. So our determinant is equal to, we say A times D minus BC, like this. Okay, so AD, that's 5 times 2 minus 3 by minus 2 there. Okay, so I'll get here a 10 and a minus 3 times minus 2, we get a 6. So our determinant is a 4. Okay, so the determinant is 4. Inverse, now we say 1 over determinant. Then we interchange A and D. So this will be a D and A there. Then our C's, we multiply them by minus there, by minus there, like this. So it means our final answer is going to be 1 over 4. Then we interchange 5 and 2. So I have a 2 here, I have a 5 there. Then the minus 3 by minus 1, I get 3. Minus 2 by minus 1, I get a 2. So this is our final answer, inverse of M. Let's move on. That was 3 marks. Matrix N is a singular. So basically when they say singular, it means its determinant is equal to a 0. Okay. Then they say find the possible values of y. You find that our n is equal to, this is our n, is equal to y squared, 3, 6, and a 2. Remember we said this is our A, our B, our C, our D. And we said our determinant is equal to A, D minus BC, like this. So doing the same for this one, the determinant is 0 is equal to A times D, that's y squared times a 2. Okay. Minus B times C, that's a 6 times a 3. Okay. So our 0 is equal to 2y squared minus 3 times 6, we get 18 there. Okay, like that. So I can take the 18 to the other side. So I'll have 18 is equal to 2y squared there. This has gone here and changed sign and it becomes a plus. Okay, now we can divide both sides here by 2, by 2, by 2. this cancels, this cancels, this 2 into 18, that's a 9. So 9 is equals to y squared. Okay, to get our y, we find square root here, find square root. These will cancel off each other. So our y is equals to a 3. Because of a square root, you can say it's a plus or minus 3 there. That's our y value. Okay, let's go to number 23. Okay, number 23, we've got this trapezium. This is a trapezium, guys. PQRS. And PS and PQ are parallel. So the parallels are showed by these things, these arrows there. Okay, then we are given the angle. This one is 90 degrees. Then PQ is 24, QR is 32, PR is 40 centimeters. Okay, fine. Let's go on. Okay, express tan RPS as a fraction in its lowest terms. Okay, R, where's R? RPS. So we want to express this angle here. Okay, so you find out, guys, if I look at this angle, we just have this value which is known, but because of these parallel sides, it means this is this angle here is equal to this angle here because of Z alternating angles, Z angles, alternating angles. So I'm going to use this angle here and say this is similar to this angle. Okay, because I have known information for this triangle here. Let me show you the triangle. Known information for this triangle there. Okay, so the information I have, I can say tan theta, remember cha, show, tau, which means the cosine, sine, and tan there. Tan is opposite and adjacent. This is my opposite, this is my adjacent there. Okay, so I can say tan theta is equal to opposite over adjacent. Tan theta, so the theta that I'm talking about is that, which is the same as that, okay, is equal to opposite, that's 24, over adjacent, that's 32, like that, okay. So we can simplify 24 over 32 there and say, okay, tan theta is equal to, tan theta is equals to a 3 over 4 there. If I simplify there and say, okay, 18 to 24, that's 3, 18 to 32, that's a 4. So the tan theta there, that's our, I'm saying here, our QRP here. This angle is similar to P, is similar to R, guys, RPS. So it's going to be equal to 3 over 4. Okay, that's done. Let's move on. We are now looking for length of RS. Length of RS. Okay, so to get your length of RS, let's go to RS. Where is RS? Okay, this is our RS here. Let me just draw RS, this one. Okay, but we now know this angle there. Okay, so I can say, remember we said tan theta is equal to opposite of adjacent. So for this triangle, I can also use the same principle and say this is going to be, my opposite is RS over my adjacent, which is 40 there. Okay, and we are going to say this, because it's the same angle as this one, is going to be equal to 3 over 4. You get it? Okay, let's go back and find that. So we are saying RS over 40 is equal to 3 over 4. Let's get our RS. RS is going to be equal to 3 times 40 over a 4, like that. Okay, so 4 here, 4 here, 1 0. So it's 3 times 10. That's our RS. So it's gonna be 30 centimeters. We are done. Okay, let's find area of a trapezium. Okay, let's go to area of this trapezium. Let me just rub off this part so that we can see what we are dealing with. And here we said it's 30 centimeters. Okay, guys, I'm going to use area of triangles, which is easier for me. I don't want to use the trapezium, but it's there. Okay, it's there. We would have to find this opposite side there, so I don't want to use it. So I can say this is my triangle 1, this is my triangle 2. Okay, so area of triangle 1 is going to be area of triangle 1 is equal to half base times height. Half base is 32, so it's going to be half 32 times height 24. When I do this, I'm going to get 2 here. 12 times 32, I'm getting 384 centimeters squared. Let's do area triangle 2. Area of triangle 2 is going to be again half base times height. My base is going to be 30 there, my height 40, so half times 30 times 40 there. 2 into 40, that's 20, so I have 20 times 30, which gives me 600 centimeters squared. So the total area is going to be, we now add 384 and 600 there. Okay, let's add those ones. We are adding 600 plus 384. Okay, if we add this, I'm getting 48, and then here a 9. Okay, so this is our total area, guys. Okay, we are done. Let's move on. We are on this number. They are saying the graph shows triangle X and C and a point Q. Okay, draw and label on the diagram triangle A, the image of triangle X under the translation -3, 2. Okay, so translation is -3 and a 2. Okay, am I right there? Okay, it's -2 and a 3. Yeah, I noticed that. That's a -2 and a 3 there. So what it means here, guys, is this. This is our X value, this is our Y value. When they say minus, you are going this side. When they say it's a plus like this, you are going to go up. Let's do that. So I'll zoom in here. Let's see. So we are moving, these values are 1, 1, 1 on Y, then are 2, 2 on X value. X is here. Let me just write there. On X, this is our X axis. Okay, then this is our Y here going up there. Okay, Y axis here. It is 1, 1, 1. Okay, so moving how many for, we are moving -2 for X. Okay, so we are moving, I will take this point and move -2, so it means I'm going there. Then I go up 3 times there, 3 boxes. So I'll move 1 box there, 1, 2, 3. So it means it's coming to this point there. Okay, then I do the same for this point, -2 and 3, it goes to this point. Okay, then the last one, this one, I go -2 and 3, it goes to this point, like that. So you find out our triangle is going to be like this. Okay, let's draw our triangle. Is going to be like this. Hey, okay, so this is our A triangle. Okay, let me just rub off this movement. So what you can check to confirm that what you have done is correct, when it comes to translation, guys, they are moving in a straight line. Okay, you can just join these points with a ruler. These should be moving in a straight line. These lines should be parallel to each other. Then it shows that it is translation. Translation means it's moving in a straight line. Okay, fine. Let's move on to the next question. Let's see the next question. Okay, we are done with this. This was 3 marks. Triangle B is the image of triangle X under rotation of 180 degrees with the center Q. Okay, let's go to center Q, 180 degrees. Okay, center Q. This is our center Q here. Okay, let me just zoom it a little bit. Okay, center Q. So this is our center Q there. Okay, so what you do, you can say, okay, fine. From each point, I'm going to move 180 degrees. You draw a straight line for these points here. Okay, so I can draw a straight line going up there. So it means this whole angle is 180 degrees. So I count how many boxes do I have for this one. You can use your compass and check. Okay, then you open up this side and you also open up. So it means this point is moving to this point there. You open up again on your straight line again, this one. It has two boxes this side, and it's going to move and go to this point. Use your compass and it goes there. Then for the last one there, you can draw another straight line passing through the center there. You open your compass, it has two boxes sort of, then it's also going to go to that point there. So you find out our triangle is going to be like this. Okay, this is our triangle and we are labeling it B. Okay, this is B. Okay, we are done. Fine, let's go to the next question. So that was again 3 marks. Okay, the last question is saying describe fully the single transformation which maps triangle X onto triangle C. Okay, let's go back. Okay, triangle X to C. Okay, fine. So what I'm gonna do is this. I'm gonna check what's happening here. Okay, let's see. You find out this is a straight line. This is a straight line. Okay, but it's changing. It was supposed to be here like this, but it's not like that. So it means this is a shear, guys. This is a shear. Okay, are we together? So we can say this is a shear, that's number 1. It's a shear, that's number 1 point. You get a mark for that. Then we have an invariant line, the line that is not changing. Your positions of your coordinates, your positions in line are not changing. You find out these are not changing. They're the ones that I have written, drawn in yellow. So it means our invariant line is y-axis. So y-axis is our invariant line. Y-axis is the invariant line. Okay, then to get your scale factor now, you can now say your scale factor is you take your original position there to get your scale factor. To get your scale factor, you say, okay, fine, my original position was this one. Let me show you. You are varying it from this y-axis there. This point is 1 distance there, over the moved there is also 1. So it's 1 over 1. But because it's going to the negative side there, opposite side of your x-axis, so it will be a negative there. So in other words, our stretch factor is -1. Even if you take this one here, it's 2 there, then it's going this side again. You find out it's the same distance. Okay, so it will be a -1 there. Okay, fine. So that is how you do it. You can as well also use what do you call it? You can as well. Okay, fine. It's okay. Yeah, let's just leave it there, guys. Okay, fine, guys. Thank you for following me and for watching our videos. Do we have another question? We have described. Okay, so now, guys, I'm going to ask you to please subscribe on Mobilemaths and like our videos, and remember to play to press the notification button so that you don't miss out on any of our videos. Okay, please wait for our paper 2 is coming soon. Bye bye.